So Shiva is the god of destruction in Hinduism, and the idea is that it's mentioned in the scriptures that Lord Shiva actually came from a different planet, from a different realm, came to Earth, resides in Mount Kailash, but sometimes has to go back to other realms throughout the universe, or different places throughout the universe. And so now when we look back at the scriptures, we now say, well, maybe Lord Shiva was actually an alien that came to Earth, shared all this knowledge about, mental well-being and, yoga and meditation and so on, but then occasionally had to go back to his home planet.
So, hello everybody. Today we have a very special guest, Rudra, who is a author, astronomer, environmentalist, and researcher. So, we are glad that Rudra is here with us. In this podcast, we are going to discuss about aliens, about some theories which we have heard about space-time theory and more such things, right? So first of all, thank you, Rudra, for taking out time and doing this podcast. So thank you so much, Rudra.
It's a pleasure. Yeah, go ahead.
Yeah. So, Rudra, I will start with my first question. What is an alien? Like in general, do we call ourselves an alien for other creatures, like maybe for other real creatures? Maybe we can call ourselves alien for other creatures, right? So, just define us what is an alien, and when this term we heard, firstly, where it came from, right? And like maybe movies, if I can remember, these terms can came from in movies. So what is your up to research set?
Yeah, so the idea of what an alien is sort of started as from a very, very, very a very long time ago, and the idea with aliens is that we shouldn't be alone in the universe, right? So
Yeah.
we shouldn't be the only life forms in the universe that can think logically, that can come up with a set of explanations to describe our reality. Um, and sort of sitting here beside nature, it sort of gives you this, it sort of reinforces that idea that, yeah, there should be life out there. Even though it may not be technologically advanced, it might be very early on in its evolution, but there should be life somewhere else in the universe. And the idea of an alien, or what we define as alien in science, is we define alien to be anything, any living organism that does not originate from Earth. So even if you have a tiny bacteria or a tiny cell or any living organism from another planet, that would be considered an alien. And so when we talk about discovering life, or discovering, traces of life on other planets, or signatures for life, what we're really detecting is we're detecting this possible signatures of these incredibly simple organisms affecting the atmosphere, or affecting the chemical composition of the planet on which they're living on. So this is kind of the basic premise of an idea of an alien. Obviously, we like to think a lot more sort of we like to expand our horizons and creativity. So when we think of alien in science fiction, we think of, these humanoids that look just like us. They've got limbs, they've got legs, they walk on 2 feet, they've got big brains, and they can think very logically, and they can, they are technologically advanced. And in the case of a lot of science fiction, those aliens tend to have more technology than us during those times. Um, the way we think about aliens actually reflects a bit of who we are as well. And I think that's a point that not a lot of philosophers make when they, or scientists make when they are on podcasts such as yours. And the idea is that when we think of aliens, we think of aliens colonizing the planet, or taking over Earth, or or destroying all of humanity and all that type of stuff. But that really is a reflection of us as humans, because we as humans, we like to conquer stuff. We like to take over. We like to well, not necessarily destroy, but sort of take advantage of the resources that are available in any particular region. That's why in the past, a lot of the wars that you see between great powers, like the United Kingdom, between Germany and all these other great powers, even the reason why European countries went around the world and colonized most of the world, including in India, is sort of this idea that they wanted to conquer, they wanted to take advantage of those resources,
Yeah.
and they wanted to prove themselves superior in a sense. We see this right now. This idea of us being extremely competitive and extremely needy for resources and growth and all that type of stuff. With this idea that with this recent tension between the USA and China. So you have this rising power, which is China in this case, and then you've got an already established power, which in this case is the United States. And the thing is that as China continues to progress and progress at a much faster pace than the USA, there's going to be a point in the future where tensions will build, and they've already started building because China is threatening that established order. And so this extreme competitiveness is sort of a reflection of who we are inherently as humans, and we sort of project our reflection of that onto any potential hypothetical aliens because we assume they would also want to conquer and they would also want to take advantage of resources and use it for their own purposes. Who knows what we want them we think they'll do with it, but what we do know is that they will take advantage and all this type of stuff. So this is kind of the philosophical aspect of why in science fiction we do get this tendency of portraying aliens as these negative things. Now that doesn't mean that we shouldn't treat aliens as these nice people who might come to Earth and they might, be all friendly and everything. That might be the case for certain aliens, who may have realized that it's better if you collaborate and share resources and bring everyone up, rather than sort of competing and fighting and all that type of stuff. Um, so in terms of the possibilities of aliens, I'm not sure if you're going to continue with this as a follow up question, but the possibility of aliens is absolutely immense. There is a large, very large possibility that we will find aliens in the coming decades. So this is sort of a brief summary of what we think of as aliens in the scientific and philosophical fields.
So, Rudra, like, do you personally believe that alien can exist? Like, I understand completely, like, if like Big Bang occurs and we can come into existence, then there are some like at least not at our level, but there must be, like as you mentioned, there must be like maybe bacterial growth or maybe at least some stages of growth somewhere in maybe other planets. So there must be there. So what do you personally believe?
Yeah, I believe that aliens should exist, and that's the viewpoint of a good majority of scientists, almost 99%. And the reason why is because if you look at the numbers of how many planets there are in the entire universe, I'll give you an example. Um, we all know that we have 8 planets orbiting our star, our sun, right? Uh, what we do know based on data that we've received through the Kepler Space Telescope is that um, there are roughly 1 to 2 planets per star. So think about it that way: 1 to 2 planets per star. We're lucky enough to have 8 in our solar system, but even taking that crude number into account as an estimate, 1 to 2 planets per star, there are 100 billion stars in our Milky Way galaxy. Sorry, 100 billion stars on average in each galaxy. Our Milky Way has slightly more, about 200 billion. But for the sake of argument, we'll just go with 100 billion for now. 100 billion stars per galaxy. Each of those stars has at least one planet orbiting around it. So you've already got 100 billion planets. And if you were to multiply that by the number of galaxies in the universe, and there's an estimated 2 trillion galaxies, 200 billion to 2 trillion galaxies in the
Wow.
entire universe that we know of. So, so you can sort of see how big the numbers get. And even if a small percentage of those planets are actually have the capacity to have liquid water on their surface, right? That's still hundreds of thousands, millions, or even billions of planets. that you still have to consider. And even out of those billions of planets, even if you assume that the probability of life forming on any given one of those planets is still extremely small, you still expect to see life somewhere. And that's kind of the basic premise. Of course, the other thing to consider is time. If you do
Yeah.
not allow enough time for life to evolve, life won't evolve. And that's kind of the beauty of our universe. Our universe is sort of on this fine balance between these cosmological parameters to allow for the existence of life. And we're quite lucky to be in a universe where, life can exist. And this is the basic premise of the weak anthropic principle, or the anthropic principle in general. And that is that an observer will always see a universe which is destined to have observers in it. So the fact that we're in a universe and we can see that there are cosmological parameters that are finely tuned, that that is suggesting that, we live in a universe where there may be more observers who are also watching. In other words, aliens. So this idea that um, the sheer chance of life forming and the number of planets, it's just a no-brainer to say that there should be life in the universe. Now, whether
Yeah.
that life actually actively communicates, whether it actively um, uh, tells us its presence, so it gives a signal and it says, "Hey, we're here, by the way. So we live on this planet. We're here." Um, that's up to them. We've already been leaking our radio signals into space, so if an
Yeah.
alien had a sufficiently large radio telescope, they would be able to observe what we are broadcasting into space, which is amazingly good. So that's kind of this idea that aliens should exist because of the probabilities. You can't you can't mess with the probabilities.
True, true. Interesting. So, like Rudra, do you think that like we are into contact with aliens because we have heard about some theories or like some news in you have heard about Area 51. There is a scientist in India called Nambi Narayan who is like who tells in one of his podcasts that NASA gets signals from some like outer space, but they're not able to decode it. And like personally, he like you believe they like he also believes that there are lives outside this planet. So, are we in touch with aliens? Like we used to hear US have some called Area 51 where they are researching about aliens or like where they have some people who are not from this earth or like this is just a mystical theory. Like we have something like this.
No. That's the straight up answer. We have not been communicating with aliens. It would be very, very interesting for us to have been able to communicate with aliens, but that would have already been the biggest story of our life, of the history of humanity. That would have already been the biggest news story. No. And the simple answer to that is that if we were already in contact with aliens, why are scientists still trying to find aliens? That's the big counter to that whole idea or that whole hypothesis. With your statement on Area 51, yes, there have been unusual sightings. There have been unusual sightings. Um, there was this there was a series of UFO videos that were disclosed by the Pentagon, um, and there were a bunch of U.S. Air Force officers who also confirmed that yes, they witnessed this with their own eyes. They witnessed these, UFOs that were shaped like Tic Tacs, and so these little peppermint Tic Tacs, and they used to fly around in the sky at multiple times the speed of sound, faster than any fighter aircraft during the time. And so, uh, look, there's credible accounts, but I won't put my bets on it yet. And the reason why is that uh, the accounts are all anecdotal evidence. So anecdotal evidence is evidence in the form of stories. So if you're providing evidence in the form of stories, to some that might seem convincing. To others, especially those who like to think in a much more logical, scientific, evidence-based manner, that's not going to cut it. You actually have to provide definitive evidence to show that aliens do exist, especially advanced aliens. Um, about your about your rumor with NASA not being able to decode signals. We get radio signals all the time, and the fact that we don't like the thing is that you really have to ask yourself, what are they decoding? Why are they decoding it? So what's the purpose of decoding a signal from space? Maybe it could just be a natural event that happens to look artificial. There was I'm sure you remember the WOW signal from the 1900s, where there was a signal which was received by a radio telescope that was so abnormally loud that they hypothesized that it could be from an alien source, only to and now there's a lot of sort of skepticism around that WOW signal because it could have just been some abnormally large radio event that was either really close to the Earth or was just some natural event from the cosmos. Astronomers tend to be very, very, very strict about when they should hypothesize whether there are aliens. If you're strictly providing anecdotal evidence, no astronomer is going to believe you. If you're going to provide scientific evidence, for example, what we refer to as biosignatures on other planets. So these are, chemical signatures that you can actually measure using spectroscopy. If you're able to find unusual biosignatures on other planets, which can only be caused by biological organisms synthesizing certain molecules and releasing other molecules as bioproducts, that's certainly more believable. There's actually a scale which was devised by astronomers at the SETI Institute. So the SETI Institute is the Search for Extraterrestrial Intelligence organization, and their job is to basically search for aliens. And they came up with this scale called the Rio scale, which will help categorize the discovery of aliens into separate categories. And so far, we haven't gone much further above a 2 or a 3 out of 10, which means that it could be aliens, but it could also be something else, some natural event that we haven't accounted for. So you have to be very careful when hypothesizing whether something is an alien, can be caused by aliens or not.
Interesting. So, Rudra, there is a theory. It's not from my side. Like a lot of people believe in this. So just correct me wrong. So it's like God. It can be called God as an alien. Let me give you an example. Like we have Shiva as a god, and people believe that uh, like Shiva can be an alien who can travel into different realms because we like stories you told, right? People have seen UFOs around Kailas Parvat. Like there are rumors, I don't know, like maybe may have some people seen or not, but there are rumors that we have seen UFOs around Kailas Parvat, and maybe Shiva used to travel with like those UFO or something like this, right? So can we call like if we believe in God, so can we call that God is an alien who created us or something like that? Do you believe in this theory?
Yeah, I've seen a lot of this. I've seen a lot of theories about this idea. So for those who are not familiar with the Hindu religion, so maybe you follow a different religion or you're atheist. Just a bit of background. So Shiva is the god of destruction in Hinduism, and the idea is that it's mentioned in the scriptures that Lord Shiva actually came from a different planet, from a different realm, came to Earth, resides in Mount Kailash, but sometimes has to go back to other realms throughout the universe or different places throughout the universe. And so now when we look back at the scriptures, we now say, well, maybe Lord Shiva was actually an alien that came to Earth, shared all this knowledge about mental well-being and yoga and meditation and so on, but then occasionally had to go back to his home planet. um and okay, so I want to tread this very carefully because there's a lot of people who have religious sentiment around this, and I do want to make sure that I'm not because I'm Hindu myself, and I want to ensure that, like, those who believe in Hinduism, but also acknowledge the fact that you also need to think from a scientific and logical mindset. So again, there are two problems with coming to this conclusion. The first problem is that again, it is a form of anecdotal evidence. So there's no scientific there's nothing really that's inherently scientific that's been mentioned, as far as I can tell, from any online resources that I've watched or read, that sort of, definitively, quote unquote, prove that, this was actually a thing that happened in the past. Um, right? There's no recorded events. There's there's no times given. It's just this sort of idea that, like, Lord Shiva came from a different planet and so on and so forth. So it's a form of anecdotal evidence, and as I mentioned before, you have to be very careful about anecdotal evidence. Even if you were to assume it's true, like, it's recorded exactly the way the original writer wrote it, because there have been many different interpretations over time. uh, then you still have to really consider, okay, it's just a form of anecdotal evidence. Is there really anything else besides that that is more scientific? You need to think in a much more unbiased fashion, because another problem that arises that leads to this biased viewpoint. I'm not calling this inherently a bad viewpoint. I'm just saying that it's very biased. Is this idea that when you look back at scriptures in the past, and you look back at those scriptures and you think with your modern mindset, right? This mindset that's been developed around technology, around the innovation that's happened in the 21st century, in the 20th century, and so on and so forth. There is a tendency to try and make patterns for the sake of making patterns. This is a psychological thing that psychologists have found in humans. The human mind is incredibly good at making patterns, even if those patterns aren't actually real. So that's why we are often really good at finding faces in things that don't actually have faces, right? It's why we're so good at finding patterns where there might not actually be a pattern. So similarly, when you actually look back at the scriptures, you're looking back at those scriptures with a modern mindset, and you might accidentally, through your own psychological bias, induce a certain interpretation. So if there's, like, this interpretation that, for example, there's a good example, like Lord Krishna in the Mahabharata, he takes he uses, there's a description of, like, some person's head that's been, attached to a bunch of sticks, and that head is just sort of flying over, and it's broadcasting the entire Mahabharat war to a bunch of people who are actually not physically at the place where the war is happening. And so many people, when they look back at that retrospectively, they automatically induce this interpretation of, oh, it's a drone. But the problem is that because you've got this modern mindset, and your mind is extremely good at making patterns out of nothing, you're actually incorrectly inducing an interpretation, which is your own personal interpretation, and may not be the true original interpretation of the of the scriptures. Likewise, another thing that a lot of people like to look at is the Hanuman Chalisa. So a lot of people claim that the Hanuman Chalisa secretly tells you the distance between the earth and the sun, which, again, it's just an effect that of this psychological bias. And it's because nowadays we know what the distance between the earth and the sun is, but now when we look back at the scriptures, we try and find a pattern, and then we find this pattern, and we induce this interpretation that, oh, they knew the distance between the earth and the sun this hundreds of years ago, whereas that may not be the case. I'm not saying it's
or
absolutely the case.
or maybe the case.
Yeah, like, that's what I'm saying. Like, you don't know what their original interpretation was, so you can't just rely on it, is what I'm trying to point out. Because you might be thinking using your own interpretation, whereas the original creator or the writer had a different interpretation of it. Um, or maybe the interpretation is exactly what you would expect. The problem is that you don't know, because you don't know the original writer. You can't just
Sure.
go up to them and talk to them and ask them, "Hey, what was your interpretation of this? Like, why did you write this down in the way that you did? Like, was there a literal meaning to this or was there a metaphorical meaning to this?" So you have to be extremely careful with scriptures because you can't just assume that your interpretation is correct.
So, Rudra, let's talk about like I have heard about axes. Like there are 2D axis, 3D axis, like uh, but there may be like four-dimensional axes, like space-time axis. So, can you explain this? What is 2D axis, 3D axis, and what is 4D axis? Or maybe there are many more axes which we have seen in the movie, Interstellar, in the ending scene. So, can you explain this?
Yeah, so what you saw in the Interstellar ending was actually just was an interpretation by Christopher Nolan, the director, of what 4D space-time might actually look like. So it was still four dimensions. It was just a four-dimensional interpretation of space-time in a sense that was shown on screen. And I feel like that interpretation by Christopher Nolan is probably the most accurate yet. It's certainly not precise. Um, it's artistically very nice, but it's not. It's the probably the most accurate form yet that we have seen of space time visualized in a movie or in a in a visual context. Um, so for those who don't know, remember back in your high school when you were in seventh or eighth standard, you learned about one-dimensional, two-dimensional, three-dimensional objects. So one-dimensional means that you've only got one axis on which you can move on, right? It's either forward or backwards. That's it. No other dimensions. So if you were to actually draw out one dimension, it would just be a line. It would just be a single line. Two dimensions means you have 2 degrees of freedom. You can move around up or down or left or right, and you can move in this 2D space in this plane that exists, right? 3 dimensions, which is the 3 dimensions that we experience, we've got points that can sort of be put around in any 3D position relative to a frame of reference which we set as our 0, 0, 0 coordinates, right?
Yeah.
With our origin coordinates. So 4D space-time is this idea that you've actually got a fourth degree of freedom, which in this case is time. So not only do you have your 3 degrees of freedom of space, but you've actually got the one freedom of time. And that's what we refer to as 4D space-time. We actually sometimes refer to it as the 3 plus 1 space-time because we say 3 dimensions of space and 1 dimension of time. However, it could actually get much more than that. So there are theories out there, like string theory, that actually state that there are not just 3 dimensions of space. There are actually closer to, 10 or 12 dimensions of space, plus the 1 dimension of time. But these dimensions, these extra dimensions, are actually curled up into these really small spaces. And so unless you're an atom or a subatomic particle, you won't be able to experience those extra dimensions, because we're just too big. So that's kind of this idea of dimensions. And the reason why we had to develop this 4D space-time picture is because of the fact that the physics just didn't work with 3 dimensions of space. Um, if we assumed that time was just a separate thing, we had 3 dimensions of space, and in those 3 dimensions, time was ticking forward, that's not a correct way to think about the universe. The better way to think about the universe was to actually treat all of them as a single mathematical entity, which we call 4D space-time. And this was developed by Albert Einstein in 1905. It is special theory of relativity. Uh, this idea, he sort of provided the framework, which then led him into his 1915 discovery that space and time are actually really interconnected in the space-time fabric. Now that doesn't mean that literally the universe is space-time. It's just it's a mathematical entity that's used to describe our universe. Maybe there is really a space-time entity, but the thing is that we as humans and any other object in this space-time actually experience 3 dimensions of space, and we experience time ticking forward, on and on and on. No one knows why we cannot experience the fourth dimension of time more freely, why time only ticks forward in one way and not the other way. But there are other hypotheses as to why that could be the case, and uncovering the true nature of time is one of the key things that physicists and philosophers are trying to understand right now.
Yeah, interesting. There is a theory I've heard around this like when you go into black hole and there is a white hole until unless you if you will not destroy it, there is a black hole and there is a white hole. When you go into that, there is another realm and time goes reverse into that. Have you heard about this theory?
With this theory, time actually doesn't go backwards. It actually will still go forwards, even if you go into the parallel universe. So even if you go into the parallel universe, time still ticks forward. Um, that is, of course, if the physics of that universe is still the same, but we're assuming that. Um, when you've got when you go into a black hole, chances are you're not actually going to see a white hole. And the reason why you don't see a white hole is simply because to keep a white hole open, you actually need this negative. You need this negative matter. So this is matter with negative mass, and we don't know of such a material in the universe. That's why we refer to it as exotic matter. um, and that's kind of the problem. Like with all these, faster than light mechanisms to travel, and these white holes and all these other, mechanics that in theory are described by Einstein's theory of general relativity, but practically not possible, all require negative matter or exotic matter, and no one knows how to make it because it's theoretically impossible. Because this negative matter will experience anti-gravity properties, so it won't actually, instead of pulling things together, it will actually push things apart. Um, some people will then claim, some people who might be scientifically minded in the audience, those people might claim that, oh, what about dark energy? Dark energy is a form of is an entity that pushes things apart. The problem is that dark energy is an energy potential within the fabric of space-time itself, and so you can't treat it as like a solid object like negative matter. You can actually create negative energy potentials, but you can't actually make negative matter in any way, shape, or form.
Interesting. So, like Rudra, I'm coming back to the Interstellar movie. Like a lot of people don't understand it. Like what happened. Like I just wanted to understand for the audience sake. Like when the main hero of the story goes into another planet, right? Mars, I guess. So he stays there for 20 minutes, and on Earth, like it it went out to be maybe 30, 40 years. So how does this work? Like when you go to space, like is there really like your time, like your aging slows or like time speed slow for you, like when you go into space or into another planet? Is there any theory
That's
behind
quite
this?
literally the case. That's actually true. Um, so you need to well, the thing is that I need to provide a bit of background for people to understand
Yeah, yeah.
why why this idea is actually true, because people will blast me in the comments. They'll be like, no, you can't have time dilation. I've actually had this before. So a lot of people who don't quite understand Einstein's theory of special relativity come into my video comments, because I also produce content myself. If it's possible, link in the description.
Sure, sure.
Subscribe. But
Yeah.
um, but this idea that Einstein's theory of special relativity implies time dilation and implies length contraction, which is another property as well, is quite weird, because you don't expect that. I mean, when we're sitting here right now, we're not moving. We don't actually have any velocity or speed, and because of that, our flow of time for both of us is actually roughly the same. The problem arises is that when we were looking at the physics 100 years ago, over 100 years ago, we were looking at the physics and we realized that certain physics does not work when you switch between reference frames, specifically when you switch between inertial reference frames. So, uh, so for a bit of background, inertial reference frames are reference frames where there is no net acceleration or no net force. And net acceleration basically means that you're not changing speed or you're not changing your direction in which you're moving. So that's net acceleration. So acceleration does not mean, your car acceleration where you speed up. Acceleration can also mean slowing down or turning a corner. There's always acceleration associated with those things when we talk about physics. So an inertial reference frame, for example, myself, I'm sitting here. I've got no net acceleration. So therefore, I'm technically an inertial reference frame. So and the thing is that in theory, if we assume that our physics is correct, we should be able to apply the same physics to me and then transform those equations using one set of rules such that we can do the same physics for you sitting in that chair right now because you're also an inertial reference frame. The problem is that didn't work. We didn't get the transformations actually broke down during certain extreme cases. And that revealed this idea that maybe the transformations aren't correct and maybe we're using the wrong implications of how space and time works. And so Einstein came along and this other physicist came along, and the physicist created this Lorentz transformation, which was an alternative way to transform the physics from, for example, from my inertial reference frame to your inertial reference frame. And Einstein used those Lorentz transformations, and he created two postulates for his special theory of relativity to make sure that all the physics still worked, such that the transformations also worked as well. And the two postulates were, number one, the laws of physics must always work the same for all inertial frames of reference. That means the same transformations, the exact same equations, all the math must be the same. The second assumption that he made is that the speed of light must also be constant for all observers, regardless if you're in an inertial frame or an accelerating frame of reference. And this was quite a leap forward in physics during that time. A lot of people had not considered that because they thought that the speed of light should vary between inertial reference frames, depending if I'm moving and the light ray is coming to me from the left, or whether I'm stationary and the light ray is coming to me from the left. The speed of light which I measure should actually be different. But what scientists have actually concluded is that the speed of light actually doesn't change. And so Einstein used that result in his postulates and basically assumed that the speed of light must be the same. Now, what happens when you have the speed of light that remains the same? How do you then explain these weird phenomena where if I'm moving relative to a photon of light that's traveling at 300,000 kilometers per second, what happens when I'm measuring it? Because the speed of light must remain the same. And the realization that Einstein came to is that the time interval and the distance that you measure is actually dependent upon the observer, or dependent upon the reference frame that you choose. So it's not an absolute quantity. And this is the core idea behind relativity, right? So this is the core framework on which the entire idea of relativity is built upon. This idea that distance and time is not universal. Even though we're sitting in different parts of the world, we're both inertial frames of references, we still might measure different time events. We still might measure different distances. And that's where this idea of time dilation comes in. So when you look at Interstellar, you're actually seeing a special type of time dilation called gravitational time dilation. And that basically means that if you are close to a really a gravitationally strong object like a black hole, you actually experience slower time. So time actually ticks slower for you relative to a person that's further away from that gravitationally strong object. In fact, without this realization, satellites would not be working right now, because as the clocks on the satellites actually drift slightly compared to Earth's clocks, and they actually have to correct for that. Without that correction, GPS satellites would actually be off by a couple of kilometers every single day, and they would just get more and more off. So gravitational time dilation is true, and we are actually using it right now to make sure that our GPS satellites are working. And the same thing is being applied in Interstellar, just at a more extreme rate. Because you're so close to this black hole, time ticks much, much, much more slowly. Compared to if you're really far away from the black hole. And that's why Matthew McConaughey and the other actors and the other main characters that were in the movie, when they went down to some of the worlds that were close to the black hole, they had to be extremely careful about making sure that they did not spend too much time there, because they knew that time dilation is a problem, and if they spend too long there, they will actually be wasting quite a lot of time once they get back up to the spaceship. So that's kind of a thing to note about. It's really cool. Interstellar is a very good movie. I feel
Yeah,
like they just lacked a little bit in the explanation. They just didn't give enough time for audiences to understand what's going on.
yeah, true, true. Interesting. I just wanted to know more about, like, we understand what is time dilation, but what do you call on like time slipping? Like, we have watched a recent series called Loki. You might have heard about this.
Yep.
So in that series, we have some paradox, and we still get confused. Ki what is the reason behind it? Like grandfather paradox. There are explanation, but I want to know from your perspective, like, what is time slipping and how it works, or is it practical also?
Time slipping is not practical. I'll just say that up front. So this idea of time slipping is that you can automatically phase between different time intervals. So you can go to the past, you can go to the future, almost instantaneously. Not true. You still have to uh, experience a certain amount of time for you to experience time dilation. So you can get very close to this idea of time slipping. So if you get very, very, very close to a gravitationally strong object like a black hole, if you get extremely close to the black hole, and you somehow make your way back, like back outwards from the very edge of the black hole, and you just manage to escape, and you escape the black hole, so on and so forth, you you will experience a lot of time dilation. Um, and you can see that as being sort of similar to time slipping, but then again, you actually still have to stay near the black hole for a certain period of time, for you to experience that time dilation. So you go in, you stay there for a little bit, and then you come back out, and you'll experience all this time dilation, even though you've been, there for a couple of minutes or something like that. So the longer you spend in a like very close to a gravitationally bound object, a gravitationally strong object, you will actually experience more time dilation. So right now, you're sitting down on the ground. Your head's, if you had an atomic clock in your head, which you don't, but let's just assume that you do, right? If you have a really accurate atomic clock in your head, that this atomic clock is actually ticking slightly faster than the atomic clock that's in your feet.
Yeah,
So the rate of time flowing between your head and your feet is actually ever so slightly different. It's just that because the Earth is not a gravitationally strong object compared to other extreme objects in the universe, it's almost not even obvious. But it does add up over time, which is quite an interesting thing because not many people think about it, but it's true. And Einstein and these scientists, what they did is that they used a bunch of different atomic clocks back in the 1900s to prove time dilation, and they were able to prove time dilation by the exact amount that Einstein had predicted, which is quite absurdly accurate. So Einstein's theory of general relativity is true. And even if you don't believe in time dilation, there are other proofs to show that general relativity is true. For example, general relativity predicted it predicted Mercury's orbit extremely accurately. Newton's laws were not able to predict it as accurately as the other planets, but Einstein's theory of relativity was able to prove that it can accurately predict the orbits of a lot of different objects, including very extreme objects, such as black holes and pulsars and all these neutron stars and so on and so forth.
Hmm, interesting. So that's up to today's podcast, and you might have learned something from this podcast. I'm sure that you are going to learn a lot more if you visit Rudra's channel. So go and visit his channel and look up to him. He's doing an amazing job. So thank you so much, Rudra, for joining me here,
Oh
and
no, it's a pleasure. It's a pleasure
thank
to be
you.
on the podcast.
Thank you, Rudra. And we'll do part two. Like, just comment us what you want to know. Like, if you have any theory, any question, anything regarding space, time, or these type of multiverse questions, anything regarding this, just comment down. We will cover in the podcast, discuss about it. We will know what are the theories, what are the research up to which we have seen. So let us know in the comments. And thank you, Rudra, once again.
No, it's a pleasure.